Hello everyone, welcome back to Ampnics. In this video, we are going to design a CAN to Wi-Fi dongle using KiCAD. If you ever wanted to bridge a CAN bus communication over a wireless connectivity, this tutorial is for you. We will go step by step through schematic design, PCB layout, and essential consideration for making this project. So let's get started. All right, so guys, we have here a fundamental block of our project, which is like you can see here five blocks: a MCU, buck converter, USB to UART, CAN, and status LED. So the main brain of whole project is this CU, which is our ESP32 board, and we all know that like ESP32 have PLE, classic Bluetooth, and Wi-Fi capability. All right, and then we have a CAN section. So basically, this CAN section will take the data and which will be forwarded to the MCU, and that MCU is connected with few status LED, which will give you real-time feedback on board. And we have a USB to UART converter. It will helps to program our microcontroller, and it will also help us to debug the microcontroller. All right, then after all these four blocks, we have another block which is a buck converter. So buck converter is responsible for providing the energy into these fundamental blocks. So before making any PCB, we will follow this workflow. All right, we will first design the schematic. After designing, we will assign the footprint of the symbols. Then after footprint assignment, we will go for the layout design, which will be the final step of our PCB design. Open KiCAD, click on file, new project. So we will make a new project here. All right, and I'll make a file. This will be ESP32 Wi-Fi to CAN rev 01. Right, so we are going to design a revision one. So for that reason, I'll put revision 1. All right, then you have to hit the save button. Okay, then we will get one schematic and one PCB folder. Okay, so you have to click on this schematic one. Right, double click on it. All right, then we have to click on file, page setting. All right, then issue the date, revision. So this is version 1. Title, CAN to Wi-Fi Converter, or you can call it dongle. All right, company. So we will put our organization name here, which is Ampnics. Comment, I'll write here designed by MD Ammar Manya. All right, I'll keep my name here. Okay, then make sure to change the size because we are going to use so many components. So for that reason, we need a bigger sheet than this. So we will take A3. Okay, then hit the OK button. All right, so as you can see here, like all the whatever the data we feed there, you can check it here. Okay, so guys, we are going to start our schematic design, and most of the time you guys ask from where you take the reference and from where you get to know about like how to make the buck converter or how to make any microcontroller designing, how you select the decoupling capacitor and blah blah blah. So what I will do, I'll share my own approach, like how I design my hardwares. Okay, so in this circuit I'm following few data sheet. For example, this MP2338, it's a high efficiency 28 volt 3 ampere 450 kilohertz asynchronous step down controller. And if I talk about the package size, which is SOT583, that's quite small. And if the features are already mentioned here, so you can read it by yourself only. And if we go down in the data sheet, you can find the typical application of it. All right, and if we go more and down, like just scroll,
Alright, so we have here the PCB layout guideline as well, which we'll see later on. And for now, you can see here typical application circuit. So if I want a 1 volt output and 3 ampere current, so I can refer this circuit. And if I want output of 1.8 volt, I can refer this circuit. Or if I want 3.3 volt and 3 ampere output, so I can refer this one. So we will need 3.3 volt. So that's why we are going to follow exact schematic of this. Alright. Then we have another data sheet which is SN65. So this is basically a CAN bus transceiver which will take the data and forward it to the controller. So we will refer this data sheet for CAN transceiver. And then we have ESP32 room 32, which is not recommended for new design. So which means if you are going to for a large production, so this is not a good approach, that you should select a product which is not recommended for new designs. So this is for educating yourself. So I'm not considering this at this moment. So I'm gonna use this data sheet. Alright. Then we have another section which is USB to UART converter. For that, I'm gonna refer this data sheet. I will mention each and every link of this datasheet in the description box. You can check that. Alright, so let's begin our schematic design. Designing the schematic, you can use the shortcut key A or you can click here. So I'm gonna use shortcut key A. I'll search here ESP32, room 32. Alright, so I'm gonna use this controller here. So double click on it and place it here, or you can place it anywhere wherever you want. So I'm gonna place it here. Alright, then we have another component which is USB to UART converter. So again press A, or you can place left click on your mouse in this sheet. So just press A. Now search CH340C. Double click on it. Alright. Then again click A. We'll need SN65. Go down and we will use this one, CAN and LIN. Alright. Double click on it. Alright, we'll use a type C connector for programming our microcontroller. So again press A and type C USB, or just search here USB C, use this one. Alright, then double click on this and place it here. Alright, then we will use a ESD protection for USB. Later on I will explain each and everything, so do not worry about anything at this moment. So we will search here USB Alright, so we will use this one. Just double click on this. Alright. Now we use OBD connector. So what is OBD connector? OBD connector is a type of connector which is used in automotive sector. So if I search here OBD connector, I cannot find it. So what I have to do? I have to download it from external source. So from where you can download these external libraries? Just open your favorite browser. Okay, so this is the website from where you can download the external libraries. There are few other websites also. You can check DigiKey or Mouser for their parts, for their footprint, for their 3D model. Or sometimes you can find the respective files on the official website of the manufacturers. So in case, let's suppose we want to use this one, so we will download this as well. So at this moment, I will search here OBD connector. Alright, OBD, and do not worry about anything. I'll keep these files in the description. so you don't need to download it from external source. But for your knowledge or for your further designing, I'm showing you like how can you do it by yourself. As you can see here, the symbol, the footprint, and the 3D model. Okay, and sometimes it happens like you cannot find the 3D model, or sometimes you cannot find the symbol, or sometimes you cannot find the footprint. Okay, so you have to then search it for its the official website. Let's suppose the Comtech is the manufacturer of this OBD connector, so you have to go at Comtech's official website, from where you have to search for it. Okay, it's a quite longer process, but yeah, if you need it, then you have to do it. Okay, then after that, let's suppose we need MP2338. Okay, I'll search. Okay, so here we have it, MP2338 GTL. So in this you can see the 3D model is available. Okay, the 3D model is available and the footprint is available, but symbol is not there. So what you have to do, then you have to go to official website. Okay, from here you have to download it, or there's another website from where you can find it, the Ultra Librarian. Okay, from here you can find the symbol, the footprint, and the 3D model. Okay, so you can download it from here. So I already downloaded each and every component which I need for this project. Okay, so I already mentioned it in the description, so you can download it from my GitHub also. So for this you don't have to worry about anything. Okay, so let's see the process of including these things in our project. So you have to go to preferences, then manage symbol libraries, click on this, then you just have to click on this one. Okay, this file icon, click on this. All right, then you have to, where you downloaded, you have to navigate there. Okay, so here I created a folder which is external libraries, so I'll click in this. Okay, so I already like MP2338 GTL is there, SS8050 is there, and COBD connector is there. So one by one I add each of them. Okay, so double click on this, just add this one, dot KiCAD underscore sim. Click on this, open. Okay, so it is included here. Then click on it again and click on this again. All right, so we need these three external libraries, so you have to include it like this, then hit the OK button. Okay, okay, then again press the shortcut key A, and now if you search for OBD, so you can see the symbol and the footprint is available here. Okay, now I will double click on this and I will place it here. And guys, if you face any difficulty while making this PCB or related to any doubt in electronics, you can make sure to join our WhatsApp community, where we used to have a technical conversation every day. Okay, so we will add our buck converter IC, which is MP2338. Okay, so keep it. Okay, then we need a choke. Okay, press A, search for ACT. Okay, here. So our most important components is available here. You can see we have our buck converter here, we have USB to UART converter here, our microcontroller is here, and we have CAN transceiver IC and the connector. Now we will add our resistor and capacitor. So for that I'll just press A and I'll just type R for resistor, double click on this, then add capacitor. So for that I'll search C, double click on this. Okay, we will need LED, so for that we will search LED. All right, so click on this. We'll add some TVS diode, and as we all know, like TVS diode is very important in automotive circuits or automotive application, because we don't know when will transient voltage can occur in the circuit. Surge protection is very important. For that reason we are going to use here SMAJ, right? I'll use this. And if you don't know about TVS diode, so do not worry about it, just do what I'm doing right now. Okay, press again A. We will use another TVS diode for CAN bus, detecting the signal of CAN bus. This Z and 2 5L Q. Okay, we need a inductor also. For inductor you just have to search L, stand for inductor. Okay, so let's start firing up the circuit. If you need more resistor, you can just click this resistor and do Control plus D. If you press Control plus D, you will get a duplicate of it, right? Then we need a few more capacitors. Let's do Control plus D, Control plus escape. Now I have to move this IC here. I have to first press escape. Okay, here, right? Take this LED here, and for moving you just have to first select it and left click on the mouse and just move it here to there, right? All right, so guys, we have completed the wiring. We will add few levels here. So we are providing the energy from here. So what I will do, I'll add a global label. So just click on this and I'll type here V underscore B8T bat, which is coming from the external battery. Okay, so we'll add and press the escape button, just connect it here. Then we need a few ground symbols, so that the terminal. So for grounding you have to click here, add power. Okay, just search for the ground. Okay, so click on this. All right, so our whole schematic for power supply is ready. Okay, let's change the value of it. All right, here we are completed our power supply. Control plus D. Then we will add one Schottky diode here. Okay, just press A, type SS34. Okay guys, we need two more transistor which I forget to insert earlier. So I'll press the key A. I'll search for SS8050. We need two transistor. Okay, okay, and I want to mirror this. So for mirroring this, use this one. Okay. Alright, so guys, we have so far covered the USB to UART converter, the power supply, and the CAN transceiver IC and OBD connector. Now we have to add few status LED and the microcontroller. So what I'll do here, I'll take the LED from here. I'll just click this LED and press shift button on the keyboard and press this for this resistor, just control plus D. Okay, I'll get the duplicate of this. So what I'll do here, I'll make at least five more LEDs. Okay. Alright, so guys, we will add few push button for our future use. There are two push button for reset and for boot, and we will add one more extra button so that if we want to increase any features in the project, so we can utilize that switch. So for that sake, again I just pressed shortcut key A and I'll search push button. Okay, and keep it here, control plus D and control plus D, right? So guys, here we have completed our whole schematic, and we have already updated each and every value. So we will add a few sections so that our schematic should be more readable. So what I'll do here, I will go in place. Okay, I'll add lines. Okay, I'll click here, add lines. Okay, then I'll make the sections. All right, yes, double click here. Okay, all right, then click on this line, press E, and I'll change the style. It would be like dashed. Okay, then you can use the shortcut key I for it, for making more section. So I'll use I. Okay, we will add a few text here, that power supply, and I'll make the size red. I'll make it bold. Okay, power supply, escape, then select the text, control plus D, this programmer slash debugger. So we can later on arrange our schematic component here and there. We can add more text, and whatever you want to add here, you can write some text and for your reference. So it is totally up to you what you want to do in this schematic sheet. We have completed our schematic. So we have here our power supply, we have here our MCU, status LED, OBD connector, CAN, and programmer circuit. All right, so there's one thing which is very important. So as you can see, we have here a VBAT, from where we are getting the current, which is our main source. Okay, then we have a V out, from where we are getting the 3.3 volt. So between this and this, I have attached a 0 ohm resistor. So this is for isolation. If you want to check this supply, if there is any problem, if you want to check it whether it is working properly or not, or if there is any problem, you don't want to damage the further circuit. So what you can do here, you can just remove this 0 ohm resistor, so your further equipment or component will not get damaged. Okay, so just like that, we have attached everywhere isolation. Okay, this is called, you can say it is a kind of isolation. So we have did everywhere, like here you can see 3.3 volt is connected with ESP 3.3 volt. Okay, so between this supply and this supply, I have added a isolation. Okay, just like this, I have did the same thing here in CAN. Okay, I have did the same thing here, and here you can see, like we have connected our external ground with the ground using isolation with the help of 0 ohm resistor. Okay, so with the help of this, you can measure the current, like if you want, if you are concerned about how much current is consuming each and every block. So with the help of 0 ohm resistor, you can measure it, because it is connected in series. So you can put the multimeter over here, and you can check the current. This 0 ohm resistor offers so many benefits in the circuit. So for that reason, I use it a lot. Okay, so almost our whole circuit is completed, but there's still one thing is missing, which you I don't think so you like figured it out so far, but I'm gonna tell you here. Like we have our MCU which works on 3.3 volt, and this device is also work on 3.3 volt. So we have our 5 volt coming from our type C charger. Okay, or type C data cable. So we will get 5 volt data here. Okay, while our CH340 works on 3.3 volt. So for that, we need to convert this 5 volt into 3.3 volt. So what I will do here, I'll connect this 5 volt to here. Okay, so what I will do here, I'll just control plus D, and I'll click here. Okay, so right, just press the escape button, and just copy this one 0 ohm resistor. Okay, control plus S. Okay, so now like everything is sorted. So it is always better approach before going for PCB layout. Always review your schematic. Once your reviewing is done, if your schematic is done, then you can make your PCB without any hassle. Okay, without any problem, like you will have enough confidence for making the layout. So it is totally up to you. The more time you will spend, the more better PCB layout or PCB you will get. Our schematic is completed. Now we will go for footprint assignment. For assigning the footprint, you have to click here. Okay, run footprint assignment tool. Double click on this. As we can see, a lot of component which don't have the footprint, so we have to assign it manually. Okay, so we'll start it from capacitor. Okay, so just click here and like press the control button, and you can select it manually, or if you want to select all together, then you have to use shift key. But we have 22 microfarad, which will use the different size package, and will here we use different size package. So what I will do here, I'll just use control button. Okay, press the control key and just select it manually. Okay, so I'll select all these capacitors. All right, so we'll go here in the capacitor section, capacitor SMD. Okay, then click on this here, footprint filters, right, and large, and we will use 0805. Okay, I'm gonna use this package, or we can use 0603 as well, if you want to make the size more smaller. So I'll choose this one. Okay, 0603. Okay, at this moment this is perfect for me. Then after that we have 22 microfarad. So use a control button, select the both capacitor, and for this we will use 1206. Okay, double click on this. Okay, then we another have a capacitor which is 220 microfarad. So for that we will go downside, and we will look for this one, and for this I'll use this one, capacitor SMD C underscore elect underscore 8 into 10.2. Okay, so double click on this. Then we have LEDs. So for LEDs I'm gonna use 0603. So select this, then press the control button. All right, now go down here and look for LED SMD. Okay, what I'll do here, I'll use SMD LED underscore SMD 0603. Okay, double click on this. Then we have a connector USB type C. So we'll go in connector USB, and we'll go for the USB C. Okay, so you can verify the footprint as well, like you have to click it and like right click on that, and you can verify it. Double click on this. Then we have connector 1 into 3. So we'll use the pin header, which is 2.54 mm, and I will use the vertical one. Double click on this. Okay, then we will look for inductor later. First we will assign the all normal components. Okay, so from here to here we will use the same package. So I'll press the shift key, and I'll go for resistor SMD. Okay, resistor SMD, the resistor okay, so resistor SMD is here. Okay, now we will select the 0603 package. Okay, double click on this. All right, so all the footprint is assigned for the resistor. We'll add the footprint of push button. So just click this one and the last one with the press, click this one and press shift key and press last one. Okay, every push button is selected here. So just go in button section, button switch SMD, double click on this, right, and then click here. Need this, double click on this. All right, then we have left one more component, which is 6.8 microhenry inductor. So we'll go in inductor SMD and we will select this one, right, and hit the OK button, right. So footprint assignment is completed. Now we will go for layout design. For designing the layout, we will click here, switch to PCB editor. All right, we will click here, update PCB from schematic, double click here. Okay, we will see this pop up. Click here, update PCB, then hit close. So our whole component is here. We will go in files, board setup. In board setup, you have to go in predefined sizes. Here in width, we have to add 0.3 mm, then 0.5 mm, then add 1 mm, add 2 mm, then for wire we will add here 0.8 and 0.5. Okay, then hit OK. Now we will make the outline of our PCB. So if I turn on the 3D view, so as you can see here, like there's a no proper PCB outline. So we have to make a proper PCB outline. So for that we have to go in layers and make sure to click this edge cuts. Okay, and we will take the reference from our components. Okay, so we will take this OBD connector here and our ESP module here. Okay, and we will make the outline on edge cut layer. Okay, so this step is quite tricky. So basically we will use here basic 2D geometry. Alright, we will make a 71 mm line from here to there for taking the reference. Okay, so click here, user drawing, and then click here. If you don't see this icon, then you can go here, place, and add dimension, add align dimension. Okay, so I will click here and press escape and press E. Okay, and I will override this value. I'll make this only 71 mm. Okay, and I'll press OK. So I drawn this line for taking the reference. Okay, so I'll shift it more. Okay, and again I want to keep the things in the center, so I will press my ESP and OBD connector, right click, align and distribute, align to horizontal center. Okay, all right, now it is aligned. Again we will go in edge cut, then we will select this line tool. Okay, so this is quite easy, but you have to make sure one thing, that you have to do it slowly, so you can achieve it easily. or there's one more thing that you can do. Like if you don't want to make your PCB complicated, you can just make a square or make a rectangular shape. Okay, you can directly just like make this kind of stuff. Okay, so you can do like this. So I want to design a product kind of stuff, so that's why I'll make my own customized outline. Okay, so click the line, and we will make equal line to this, and okay, then we will make here about 7 mm. All right, then we'll go 3 mm here. All right, then we will go 11 mm. Okay, and then we will go 1 mm here. Just leave this place and select here, draw arc. Okay, so all right, then press escape, again line 1 mm, then we have to go 40 mm, 40 mm straight line, and make sure to check the angle, is it properly 90 degree or not, because we need it 90, otherwise it will be like a slanted line. So we don't need slanted line, we need proper. So I'll press escape, and what I will do now, escape, and I'll just copy this arc. Okay, for copying this, control plus D, and it is tricky, but if you just like spend some time, you can achieve it. That's not that much complicated. Okay, so now we will make it 9.5 or just 9 mm. Okay, we will match this with the outline. Okay, so I think we should take it about escape, escape, delete this line, again I'll take the line from here, and I'll make a single line, not double. Okay, 9.5 is fine, I guess. Yes, it is fine. 9.5 is fine. Okay, now we will take 6 mm. Okay, 6 mm depth. Then basically it is an antenna section, so we don't want to have PCB downside. Double click it, and we will check this value. Okay, what is the dimension of this? Okay, length is about 14.5. Okay, so we just want to make it identical from both sides, so for that reason we will keep it same. Okay, it is same, that's not a issue then. And this dimension is about 9.5. Okay, all right, 9.5, then 1 mm inside, double click here and escape, press this arc, control plus D, R. R means R for rotation. Okay, join this here. Then again I'll make another duplicate for here. Okay, I'll keep it here. Then again go in the line section and we'll make 1 mm. Then we'll go straight. What was the value of this dimension? Let me check it again. So 40 mm. Okay, so we will go straight 40 mm. Then 1 mm inside. Double click, escape, just shift this arc here. And again, what's the dimension of this? E11. All right, so we will take the line 1 mm, then 11 straight. All right, then we have to take 3 mm inside, and here we go. All right, so our PCB outline is completed, I guess so. So let's see. All right, so our outline is completed. Now we will shift our components and we will make our tracks. Now you can see our whole placement is completely done. Now we will go for tracks. Alright, so here we completed our whole PCB. We added each and everything, like there's a copper fill area, we added the text and we routed our tracks. So as you can see, like there's only one thing to notice, like each and every text there's no 90-degree curve. Okay, there's no 90-degree tracks. Each and every track is only about 45-degree, because this is the best approach to make the tracks. Okay, so you always have to keep in your mind, if you make it more circular, that will be more better, but it is always to go with bare minimum, that is 45-degree. Okay, so always you have to make the tracks like this only. You have to avoid direct 90-degree connection. Okay, so this is one of the best approach to make the tracks. So we already covered the tracks and all. Let's see the 3D view of our PCB. Just click here. All right, our 3D viewer is open. So as you can see, there are few components which 3D model is not available, so we will add in it. Okay, so how can we do that? Just go in layout editor. First we will add this OBD connectors step file. Okay, press E, just go in 3D model plus here and just click here. Okay, and now you can see like our whole component is available on the board. So this is the final look of our PCB. Okay, so I'm not a huge fan of green color PCBs. I like black color. So you can change the color of your PCB by clicking here. Okay, just double click here and I'll take the black color. All right, then if you just flip it, okay, it is still green, so I'll double click here. Okay, and then I'll select black. Okay, so now it is turned black. So in this way you can check and you can verify like how will be your final PCB will look like, and you can have a taste of your PCB by viewing it. Okay, and let me know one thing in the comment, like rate it on a scale of 10. All right, each and every respective file is in the description. Make sure to check the description and download all the respective file from my GitHub. I had already uploaded each and everything there. You can download it from there. So in this lecture we learned about how to design a CAN to Wi-Fi converter, or you can say a CAN to Wi-Fi dongle. So this was the complete lecture on it, and I know it was a bit long, but you got to learn so many things in this video. So make sure to like this video and hit the subscribe button for more content.